Okay, so we've been talking about electron location in this unit. And we started out with our model of the atom. We saw how it transformed throughout the years. And what we've taken a look at now is we have kind of two models. We have our Bohr model, which we called our helpful model. We use this to kind of visualize where electrons exist in an atom. And then we have our more updated version of the model, which is the most correct model we have so far, called the quantum mechanical model. And that one says that rather than electrons existing in these orbits, in these rings around a nucleus, instead, electrons can kind of exist really wherever they want. They move around the nucleus, but we can kind of guess their location. We can estimate their location through really complicated probability calculations. So through these probability calculations, you can say that an electron probably exists in this location, but we can kind of visualize a little bit better where these probable locations are using something called electron configurations and using something called orbitals. So all of these different orbitals are essentially places that electrons can exist, and there's four important things that we need to know about them. If you are going to take AP Chemistry, please pause the video, go back and do the pair deck first so you have that information available to you before jumping into this lesson. If you are not planning on taking AP but you want extra information, you're also welcome to complete the pair deck. But they have I put some together kind of a little bit of like background information you might want to know before heading into this lesson. But if you're just doing the lesson, not planning on taking AP Chem, you can dive right in now to electron configurations. So essentially, these orbitals are areas of electron probability, and these electrons do exist in these energy levels, and every orbital has kind of an energy level associated with it. So we know that electrons exist in energy levels. Within those energy levels, there are sublevels composed of different types of orbitals. So an orbital is a sublevel within an energy level. And these orbitals are areas of electron density. So this means we are likely to find an electron in an orbital. And there's a couple different shapes of these orbitals. So to help us determine these probable locations where we can find these electrons, we're going to write out what's called an electron configuration. So in each electron, each atom has what's called quantum numbers that are associated with it. And it's kind of like an electron's address. It tells us where these electrons exist. So for the purposes of this class, again, if you're not taking AP, we're just going to worry ourselves with learning about how to write full electron configurations for atoms. We're not really going to concern ourselves too much with the difference between the quantum numbers. So there are four different types of orbitals. The ones that I have listed here for you, S, P, D, and F, this tells you their shape. So the shape of an orbital can be an S, P, D, or F orbital, but those are the four types of them. Every individual orbital can hold a maximum of 2 electrons, and each type of orbital has a different number of sublevels associated with it. So for instance, if we look at this table here, an S orbital has 1 orbital within that S. So if I scroll down to look at the shape, this is an S orbital here. It's just a sphere, and this 1 S orbital has 1 sublevel, 1 orbital in it, and that orbital can hold 2 electrons. If we look at the P orbital has 3 sublevels, so 3 orbitals associated with it. So since each orbital can hold 2 electrons, we have 3 times 2 gives us 6 electrons that can possibly fit within a P orbital. So if we look at the shape of these, this is what a P looks like. These are drawn in kind of 3-dimensional space, so you can see it in 3D, but a P looks like if you took an oval and you kind of squished it in the middle. or like a little bit of a squished 8, an elongated 8. That's kind of what a p orbital looks like. So p orbitals the atoms exist in 3 dimensions, so our p orbitals exist in 3 dimensions. This one can move up and down inside your paper. One can move left and right inside your paper. And then the last one looks like it's coming out at you, and part of it is going into the paper. So that's what these 3 different drawings are representing. A d orbital has 5 sublevels, can hold 10 electrons, and f orbital has 7 sublevels and can hold 14 electrons. And these are the shapes for those. As you keep going, they start getting gnarly and gnarlier in terms of their shape. So every orbital can hold a maximum of 2 electrons. And we are really not going to focus too much on f orbitals in our class. We will get to d, but really we're really not focusing on f. So you will never have to draw all of these crazy shapes down here. I just want you to know what they look like. So how can we use this information? So to determine an electron's address, where it exists, there's a few things we need to know about it. We can visualize it using a ground state orbital diagram, and we can just write it out using an electron configuration. So I want you to go through this worksheet right here. It kind of walks you through how to draw these orbital diagrams and write an electron configuration. I will say this is information that you can find in the lesson right here, but just to make it super clear, this piece is the orbital diagram. The visualization, this piece is the electron configuration, just the numerical representation of an electron. All right, so you're going to go through, complete this entire worksheet. I recommend please completing it on your own, but I will have an answer key posted for you to check your answers once you're finished with it. Once you're finished, submit your copy to Neo as well, please.